This is a lesson on calorimetry. Calorimetry is the study of heat, or the measurement of heat. The instrument you use to study calorimetry is called a calorimeter. A calorimeter is essentially an insulated container where you can measure the temperature with. The basic idea between calorimetry is heat lost must equal the heat gained. If something loses energy, it must go someplace. So it goes into another substance and warms it up. Since heat loss is mc delta T, and heat gained mc delta T. Now these are different mc's and such because you wouldn't be useful to do the same thing both times. So this is the hot stuff because the hot stuff loses, and this is the cold substance because the cold stuff cools down. For example, suppose you have 30 grams of a substance which we don't know specific heat is put in boiling water, and the boiling water is 100 degrees Celsius. At the same time, we have a container, or a calorimeter. A calorimeter with 125 milliliters of water, but through the miracle of science and scientific method, or scientific metric system, you have 125 grams of water. 1 milliliter is 1 gram, so 125 milliliters is 125 grams at 22 degrees. You remove the substance and you put it into the water. The substance is placed in the water. The substance is placed in the water, and the final temperature is equal to 25 degrees Celsius. What is the specific heat? What is the C of the substance? Go through the line and figure out. 30 grams of substance is starting out at 100 degrees, so that's the hot stuff. So it's 30 times C, which is what you're trying to find out, times the change in temperature of the substance. The substance started out at 100 degrees Celsius, and you started out at 22 degrees Celsius of the water, and you ended up at 25 degrees Celsius. Put them in order from highest to lowest. The hot temperature goes from 100 to 25, which is 75 degrees. The mass of the cold substance, which in this case is water. Now they don't mention the specific heat of water, but we should know that's 4.18 times the change in temperature of the water. The water started at 22 degrees and went up to 25, which is a change of 3. Solve for C, and you get a value of 0.700 joules per gram degree Celsius. There's another type of problem that you can do. Let's do the same type of substance, same question up here. Everything's the same up above except the substance has a specific heat. Of 0.70 joules per gram degree Celsius, and you put it in water. You're starting, the substance starts at 100 degrees Celsius. The water, 125 milliliters. And the water starts at 22 degrees Celsius. You have 30 grams of the substance. And the question is, what is the final temperature? You set it up the same way, except the temperature will contain a variable. So you have 30 grams of the substance. Specific heat we now know is 0.700. The temperature started out at 100 and it went down to the final temperature, which we don't know, which we'll call F. The water is 125 milliliters. Water is 4.18. And it started out to get a positive number, the final minus the cold temperature, which is 22. What you can do is multiply this together, divide both sides by 125 times 4.18. Find out what that is. That's about a third, fifth, 20. Let's call it, just giving you a number, 0.05. Let's just say that's 0.05. 100 minus F equals F minus 22. So what we did was we got rid of this and moved it over there. Now you distribute times 100 is 5 minus 0.05 F. F minus 22. Add 0.05 F. Add 22. 27 equals 1.05 F. And solve. Which isn't too bad for approximation. Whatever that is will be your final temperature. This concludes the lesson on calorimetry.